welcome chemistry students. Today our learning goal is to learn about the nature of bonds. We know how to draw Lewis structures already. We've practiced that. We are going to discover the difference between something called polar bonds, nonpolar bonds, and ionic bonds. So let's get to it. Take a look at this chart above you here and try and remember back to when you were 15 years old, grade 10. What is the difference between covalent and ionic bonds? Pause the video and try and think on your own right now. What do you know about each? If you remember correctly, you should remember that covalent bonds are sharing electrons, while ionic bonds are stealing electrons. The thing that both of them share in common is that they're trying to achieve the octet, a full shell. Try and recall how we draw the Lewis structures differently. Think about it a moment, pause the video now, and try and think how we would draw them differently. Take a look again. You draw your Lewis structures for covalent as the bottom right here with lines. The top one that I have here is called the Lewis dot diagram. You have sharing electrons. And again, everybody has the octet here. The key difference is that ionic compounds contain ions. So what is the definition for bonding in general? Well, chemical bonding is the attraction between atoms holding them together to form compounds, either ionic or covalent. The atoms are more stable in compounds because they have achieved the octet. Now, I don't know if you knew this, but there's actually three types. There's ionic, covalent, and metallic. We're going to learn today that there's actually two types of covalent type of subgroups that we call. One is called polar and the other is nonpolar. We're going to discuss those right now. So ionic bonding is when you have two atoms exchanging electrons. One gains them, one loses them. And generally this happens, ionic bonding happens when you have metals and nonmetals. And the reason is because metals generally have a low electronegativity, and fluorine and other nonmetals have a very high electronegativity. You have a weakling and a bowling. As a result, you have the following. You get stealing occurring because one atom really, really wants them, and the other one says, hey man, I give up, you got them. What you get is two atoms that are isoelectronic with noble gases. They have full shells. You have a cation, a positive ion, and an anion, a negative ion, that stabilize each other and neutralize each other overall. So for this compound, NaF, sodium fluoride, it has no overall charge because it has one positive, one negative. Next, we have covalent bonding, and generally it's nonmetal atoms that share electrons to complete the octet. Now again, we have two types, nonpolar covalent bonds and polar covalent bonds. Nonpolar covalent bonds are described as atoms that perfectly share. Polar covalent bonds are unequal sharing. Again, it's the example as if you're sharing with your brother or sister, and oftentimes it ends up as being unequal sharing. Your older brother often wins out more. So the more electronegative atom ends up getting the electrons closer to the atom. So chlorine has higher electronegativity than hydrogen. When they bond, the electrons end up closer to the chlorine. So as a result, electrons move towards the chlorine. Chlorine will get a slightly negative charge. We write this partial 8 charge, which means partial charge, and partial positive charge for hydrogen. For a nonpolar bond, the electrons show that there's no arrow that we draw. The electrons are shared equally between the atoms. The key thing that you need to understand is that the higher electronegativity atom wins the electrons. The arrow points towards the more electronegative atom and gets a partial negative charge. The atom that loses its electron in the sharing becomes partially positive. So we need to know that the type of bond, ionic or covalent, or polar or nonpolar. I know I didn't talk about metallic today. We're going to touch on that at a later date. But really, the type of bond, either covalent or ionic, is determined by the difference in electronegativity. What is electronegativity? Well, electronegativity is the ability of an atom to attract an electron in a bond. So if we have a very large difference in our electronegativity, between 1.7 and 4.0, what we have is an ionic bond. If we're between, sorry, a very little difference between 0 and 0.3, we are a nonpolar covalent, okay? And if we are between 0.3 and 1.7, we are polar covalent. And this means we have to include something called dipoles, which I will define in a moment. So let's look at three examples: HBr, SRO, and Cl2. I'm going to draw the Lewis structures really quickly for each one of these compounds. So as you can see, I drew the Lewis structures for each one of these compounds. Now, I knew that SRNO was a metal and non-metal, so I drew it like it's ionic. But we're going to check the electronegativities now to check to see if we have a polar or a non-polar bond. So I will show you an example exactly how you do HBr. So we must find H, and we have to take a look at bromine right here. We need to find the difference in electronegativity. Let's zoom in and take a look. You can see that hydrogen has an electronegativity of 2.2, and bromine has an electronegativity of 2.96. So this is important. We always take the higher electronegativity, subtract the lower electronegativity, and we get a difference in electronegativity of 0.76. Let's look at our chart to see where it falls. Our chart says that 0.76 is between 0.3 and 1.7. We know that this is in a polar covalent range. Because this is polar, this means that we have to draw a dipole towards the more electronegative atom. Dipole shows the direction in which the electrons move. The positive end is where it's moving from, so therefore you get a partially positive charge and a partially negative charge on the other ones. Let's look at the difference in electronegativity for these two atoms, SRO and Cl2. So if we subtract the electronegativities, the higher one minus the lower one all the time, you find out you get 2.50, which is indeed an ionic one. We expected it to be ionic because it's a metal and non-metal. And the difference in electronegativity between chlorine is obviously going to be 0, and that is a non-polar bond. It does not contain any dipoles. Remember, the only ones that contain dipoles are polar bonds. You have to show it pointing towards the more electronegative atom. Show your partial charges. That's it. Remember one more thing, that you do have a chart on your periodic table. You have this chart right here. This chart is on your periodic table. You can look at it. You don't have to record this. We'll talk about that more tomorrow. Enjoy the rest of your night. Thanks for listening.